The ethereal virtual machine is a very important part of the ethereal blockchain. It plays an important role in the storage, execution, and the validation of smart contracts. Today we will dive into EVM data storage mechanism and security issues. What is EVM? EVM is a lightweight virtual machine, and code running in EVM cannot access networks, file systems, and other processes. In this way, the Ethereum network can safely run smart contracts without being affected by abnormal termination of smart contracts or external environment. EVM storage location and its meaning. Stored data is classified into two types: non-volatile data that is not easily lost, and volatile data that is easily lost. Data that is hard to lose is stored in cold and storage, while data that is easy to lose is stored in stake, arcs, and memory. EVM data persistent storage mode. Storage is the place where each contract stores data persistently. The way of storing data is realized through slots. Persistent storage of data can be realized by state variables, structures, maps, arrays, byte arrays, and strings. By state variables. Variables or contracts up to 32 bytes in size are stored at their index value in the order they are defined. For continuously small values, it may be optimized to store them in the same location. For example, if the first four state variables are type unit 64, the values of the four state variables are packaged into a 32 bytes value and stored in position 0. By structures. The same is true for structures with size up to 32 bytes. For example, if the structure variable's index is defined at position 0, and there are two members inside the structure, then the two members are 0 and 1 in order. By mapping. The map storage location is calculated using the method shown in the figure. Position indicates the location where the storage variable corresponding to the key is stored. Through the array. Arrays are also divided into fixed length and variable length arrays. Fixed length arrays are stored sequentially as long as they are up to 32 bytes. But the compiler does a boundary check at the compile time to prevent them from crossing boundaries. Since the length of a array length array is variable, storage space is usually reserved in advance during compilation. So the location of the state variable is used to store its length. The specific data address is computed to get the first address of the array, plus array length offset to get the specific element. Byte arrays and strings. When the length is less than or equal to 31 bytes, fixed length bytes arrays are stored in the same order. For variable bytes groups and strings, 0 up to 32 bytes are added to the stored value, and the last byte of the added 0 is used to store the encoding length of the string. When the section arrays and strings are longer than 31 bytes, the variable location stores the encoding length, and the encoding length formula is changed. The first position of the real stored value needs to be obtained through the formula, and the rest of the value is stored in order of the obtained position, and the last stored position is supplemented with 0 to 32 bytes. EVM security issues. Bug principle. Structs, arrays, and mapping local variables mentioned in the official manual are placed in storage by default. The default types of local variables in Solidity language depends on their own types. Therefore, if the above storage variables are set inside the function but not initialized, they are equivalent to storing pointer to other variables in the contract. When we change it, we overwrite other variable data to which it points and creating a security hole. As you can see, the EVM store is a key be equal and greater than value database. A stored data can be checksummed to ensure consistency. It also interacts with smart contract language. When some of the rules conflicts, it's likely to be used by people with ulterior motives. Therefore, a standard use of smart contract language is a necessary condition to avoid security hole.
区块链安全小课堂，你学会了吗？快关注我们的公众号和官网。